get into how to charge different objects today. So there are three ways. We're on page 14 in your book. I've just got the outcomes at the top. So we've got three ways that we can charge objects. So the only reason we're able to use electricity in our modern world is that it's possible to separate positive and negative charges from each other. So there's three different methods of separating these charges from each other. So we're going to get into each one of them below, but I think I'll just write them up here. So we can charge by friction, by conduction, and conduction is the fancy word for charging by contact. Friction is the fancy word for rubbing. Or we can charge by induction, coming near something else. These are tricky concepts. Friction students usually catch on to pretty quick, but conduction and induction and the resulting charges in the objects can be a little bit tricky. And obviously this is my first time that I'll be teaching it when we're not in class, and I can't show you demonstrations, or we can't try them on our own because everybody will have different materials at home. So if you can just maybe watch the video a couple of times, and be sure if you have questions about anything to send me a message, and we can arrange a chat or like a phone conference or a video conference. So the first method is charging by friction. So one way to do this is by rubbing two different materials together. So we charge by rubbing. So this we talked about in the past, rubbing your socks on the carpet, rubbing a balloon on your hair. That's rubbing two different materials together, and we can generate a charge like that. So since the objects are made of different materials, their atoms will hold on to their electrons with different strengths. As they pass over each other, the electrons with weaker bonds are ripped off that material and collected on other materials. So if we had a balloon and we were rubbing it with, say, a piece of wool or fur, basically that balloon holds on to its electrons really tightly, so it's going to rip off electrons off of that fur or wool or whatever we're using, and there, since the balloon is an insulator, it's going to hold those electrons right on the spot that was rubbed. Charging by conduction means that the two objects will come into actual physical contact with each other, and this is sometimes why it's called charging by contact. I don't think there's anything now. So here we have some different diagrams, and I've kind of gone over them in pen just because they're a little bit light to show up. So hopefully they're kind of better in your handout. So figure 2A here, we have charged and neutral objects. So here, this object is neutral, and in your book, it's just grayed out. I've added some charges to show that it's neutral because there's 3 positive charges and 3 negative charges. So positive and negative are equal and opposite, so they kind of cancel each other out. This rod up here is negative. And this particular diagram's only shown the negative charges. It's really only showing the excess negative charges. In reality, that object would still have some positive charges, but it's just shown the excess negative charges. As we bring the objects near each other, we see this separation of charge. So what we see on our neutral kind of sphere here is that when we bring that negative rod near it, all the electrons are repelled away. So they move to the far side. And that separates the charges. So we have a slightly positive charge at the top here, right? This kind of becomes positive, and this back here is kind of negative. So we've separated those charges. In conduction, there would be actual contact between them. So there's actual kind of contact or touching. So when they touch, what we see is those negative charges would actually move. The electrons would actually move from that negative rod onto that neutral sphere. So afterwards, this rod up here, it's still negative. It's not going to give away all of its excess negative charges, but this ball down here will have picked up some of those negative charges. So if we count them, there was 3 positives and 3 negatives. Well, now we have an extra 3 negatives as well. So this has 3 positive. Now it's got 6 negatives. So overall charge is negative. Overall charge over here is negative as well. So I'm just going to read through the explanation that's at the bottom of your page in your book. So in the diagram, there's a neutral loonie that has equal amounts of positive and negative charges, and I wrote those on for you, and a negative rod coming near it. So I think there's a typo there, so just make sure you change that here to near. When the charged rod gets close, the charges in the neutral loonie separate. So the electrons those negative charges are repelled away from that negative rod. When the rod touches, the electrons jump from the negative rod onto that neutral object, causing that neutral loonie now to have more electrons than protons and making it negative. So here's a really important thing, and you might want to highlight it on the bottom of page 14 in your book. The neutral object will always take on the charge that the rod holds when charging by contact or by conduction. So same idea here. I think I'll just erase this and redraw it for you. It'll work exactly the same way if it's a positive object as well. So again, I'm just going to erase it. If we have kind of our loonie or whatever here, it's going to have equal positive and negative charges. So here are my positive charges. I'm going to evenly spread those out because remember, in real life, they absolutely would be kind of evenly spread out. Here's my negative charges here. And again, if I have 3 positive charges, to make it neutral, I also have to have those 3 negative charges. And again, they'd be evenly spread out. If I have, and I'm going to use my finger and kind of draw things on now, if I have this rod, and I'm just going to show the excess positive charges, again, in reality, there would also be some negative charges. As it comes near, what happens is those electrons, now this time they aren't repelled away, this time they're attracted because we know that unlike attract, and when they touch, those electrons are actually going to move from the neutral object onto my positive rod there. So that would leave less electrons on the neutral object, making it positive, and this is going to gain, the positive rod's going to gain some electrons, but not enough to cancel out all the positive charges, so it would also still be positive as well. So it works both ways, no matter if the object is positive or negative. When we charge by induction, we're charging by bringing an object near another object. So we're charging an object or a conductor without coming into direct contact with it. So we have to follow some special procedures, and the most important one of those is using a grounding wire. So basically, same as what we did on the conductor one, is we're going to separate those charges, and then we're going to use that grounding wire to take away those excess charges. So a grounding wire is simply a conductor that connects the object to the ground. So you can think of the Earth as a huge reservoir of charge. It can both gain or donate electrons as needed. Depending on what the situation is, electrons will either travel up that grounding wire to the object being charged or travel down the grounding wire. And the Earth is so large that an excess of protons or electrons doesn't make a difference in the grand scheme of things. So we've got some diagrams here. So here is my neutral sphere. I know it's neutral in 3A because it's got 3 positive charges and 3 negative charges. This here with the 3 lines at the bottom, that indicates a ground. So this is a grounding wire. 3B, I get this separation of charge. It's called polarization when we are talking about induction. I bring my negative rod near. Those electrons in the neutral sphere or loonie try to get as far away as they can. And in this case, because we've got that wire, those electrons will travel down the wire. If I snip that wire, so they're in red here is my scissors. If I snip that wire while that neutral or that charged object, that negative object is near my neutral object, I'm going to have basically trapped all those electrons down at the bottom here. And when I remove my neutral object, you'll see it's gone from figure 3D. When I take away that charged object, my negative object, because that wire is snipped, the electrons can't come back up. So afterwards, this is positive. So what you're going to notice is that in the diagram, there's a neutral object that has equal amounts of positive and negative charges, and a negative rod again coming near it. When the charged rod gets close to the neutral object, the charges separate and the negative electrons are repelled away. So they move so far away, they actually move into the ground to get as far away as possible from that negative rod. So when we snip that grounding wire, the grounding stops, we're left with a positive object. So the neutral object always takes on the opposite charge of the rod when we're charging by induction. So again, I've highlighted that, so you may want to highlight it on the bottom of page 15 so that you can get that kind of main point, because that'll be some of the questions we ask. Just going to do a couple notes on the top of page 16, and then we're going to leave the rest for another day. So conductors versus insulators. The result depends on if the material used was a conductor or an insulator. So again, conductors are things like metals or salt water. If materials are conductors, the charges will flow easily from one to the other and spread out. So examples of metals are gold, silver, copper, aluminum. Insulators, materials are insulators if only the specific areas that are actually touched would show any change in charge. So that's because the charges can't move easily through those insulators. So that's where we're going to stop today. We'll pick up tomorrow on the bottom of page 16 and the attraction of neutral objects. Hope that helps.